Hello and welcome, everyone. We're going to get started in just a moment or so. We'll let folks trickle in. All right, well, I'm seeing some of our numbers level off, so we'll go ahead and dive in. Welcome, everybody, to for joining our webinar today. This is our final webinar of our summer series. Thank you for joining. We're going to go ahead and get started here. We are dedicated to bringing you the latest actual insights from Better Buildings, bringing together leading industry experts through our webinars by offering a chance to explore differing topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency strategies and reduce costs. If we go to the next slide. Today's webinar in particular, the final of our summer series, is called Powering Progress, Strategies for Efficient and Reliable Central Plants. And before we dive in, just a few housekeeping things to note off the top. Today's webinar will be recorded and archived on the Better Buildings Solution Center, and we will be following up with today's recording and slides when they're made available after the webinar. Next, you'll note that attendees are in listen-only mode. This means that your microphones have been muted, but if you do experience any audio or visual issues throughout today's webinar, please go ahead and send a note and message in that Q&A box located at the bottom of your Zoom panel, and our tech support team will be in touch. If you go to the next slide. My name is Bree Cullen, and I serve as a program lead with the Better Buildings, Better Plants initiative. Thrilled to be here with you today. If we go to the next slide. For today's agenda and this webinar, we're excited to start off with some welcome polls, get an understanding of who's in our virtual room today. We'll be kicking it on over to one of our working group leads, Nora Hart from Lawrence Berkeley National Lab. She'll share some takeaways and summaries from our recent Central Plant Efficiency Working Group. Next, we are joined by some amazing partner speakers coming from, first off, the Commonwealth of Massachusetts, as well as a higher education partner from Carleton College. And then we will close with Q&A at the end. If you go to the next slide. We will be using today an interactive platform for Q&A and polling called Slido. So folks want to take a moment or so to access Slido by going to www.slido.com on either your mobile device or opening a new window on your internet browser. Today's event code is #or#DOE, and you can also click that link in the chat to access Slido directly if that's easier. Throughout today's presentations as well, if you do have any questions for panelists, you can submit them utilizing this platform, and then we will go ahead and answer those questions towards the close of the webinar. You're then able to also select thumbs up for questions that you like, which will then result in the most popular questions being upvoted and moving to the top of the queue. So we go ahead and transition to our first couple polls. First off, we want to learn a little bit more about those folks in the room. So feel free to join us over in Slido and respond to some of our initial questions. And again, if you do have any tech issues, please go ahead and send a message to our tech support team utilizing that Zoom Q&A function. All right, so first off, understanding which sector folks are coming from attending today's webinar live. I'm seeing right off the bat, we have some great government representation, folks from the commercial sectors as well. We know central plants too really resonate with oftentimes some of these larger buildings, campus facilities as well. So see a good representation from some educational folks and sectors, industrial organizations as well. Wonderful to have you all here in a good mix. Seeing multifamily facilities, and I know it's a big and popular facility component within healthcare as well. Perfect. Well, feel free to keep inputting information to that. We can move to the next poll. And this is also just to get a better understanding of folks in the room in terms of what particular roles and functions that attendees play in your organization. See, we have good representation across energy managers, facility managers here towards the top. Those that may be specialized in capital planning or project management at their organization. I know these types of large, substantial capital projects involve a village, many different entities. So thrilled to have so many varying representatives across organizations and the varying roles and interest in this topic in particular. I'm seeing a clear winner with energy managers, so not surprising. Wonderful. Well, thank you for continuing to input that information. We can go to the next poll. And transition to the next slide. Okay. Alrighty. I'm seeing folks input into answering some of this initial question in terms of what phases have others completed, potentially at organization, in terms of assessing your central plants. Might be first off defining needs. Maybe you're looking to and exploring and evaluating in particular variety of CapEx solutions. This might be giving a little spoiler too to some of what the content that Nora is going to share in a moment. So we'll let folks respond to some of this question and share more context, and then I'll transition over to our first presenter. But we'll take a moment or so. See folks working through some conceptual designs and implementation. And everyone's at varying stages of their journey. And so folks may be going through some initial conceptualizations, thinking about what's possible, and coming to this webinar to learn a little bit more about what folks have done in this space. So if folks haven't started, that's okay. And we see a good representation too of folks wanting to learn a little bit more in these initial stages. So it seems like some of the majority is definitely working through defining those needs. So we'll go ahead and start off. And I'll transition over next to Nora Hart from Lawrence Berkeley National Lab. Thanks, Nora, and thanks, folks, for participating in those polls.
Awesome. Thanks, Bree. So as Bree said, I am Nora Hart. I work for Lawrence Berkeley National Lab. I'm an energy technology researcher there. And prior to the lab, I was actually sustainability and energy manager. Great to see a lot of you on the call. I'm glad this content. If you go to the next slide, I will give just a brief overview of our central plant retrofit working group that Bree alluded to. So this working group kicked off in the fall of 2024. We just wrapped up. A quick shout out to all of the Better Climate Challenge partners that participated in this central plant working group. We had 28 partners and allies participate, and we couldn't have done it without them. Over the course of 5 meetings, we discussed a lot of topics all around central plant retrofits. And from that, we've developed a report out that gives an overview of some of those discussion outcomes, key takeaways, etc. So I will start going over those on the next slide. So here are some of our key takeaways from the working group. Everyone that joined the working group were either thinking about retrofitting their central plant, they were in the process of planning, or they had already done it. So similar to those phases that Bree went over, people were all over the place with where they were in their central plant. And these were some of the biggest challenges that we saw. So meeting peak loads, space constraints. So literally, where do I put this new equipment that I want to install? Steam to hot water conversions was a huge challenge. And then, as usual, high capital costs. On the next slide, I'll talk a little bit about some of the solutions that we discussed. So building heating and cooling demand reduction was huge. And by that, we mean all of those buildings served by the central plant, start there and try to reduce your demand, make those buildings more efficient. Lowering the supply water heating temp was huge, and you can do that through a process called thermal optimization testing. We like to call that how low can you go? And then some of the other solutions were energy recovery, completing an electrical service assessment or electrical load study to determine if you need an electrical service upgrade for this new equipment you're planning to install, completing incremental retrofits, and finally assessing multiple options. So making sure that when you're looking at solutions, you are working with a design engineer to see what's possible, because there's not going to be a one size fits all. Next slide. All right, so one of the biggest things we learned from the working group and from those outcomes was determining that owners really needed some guidance on how to complete a central plant assessment. And from that poll that Bree just executed, I saw that a lot of you were in this phase one of defining needs, which is great because I think some of this content will help you out. So what we talked about with the group during the working group is, okay, if you're taking on a central plant retrofit, what is the process? How do you go about this? And so from all of those conversations, we were able to define these 4 different phases. So I'll talk a little bit about each one of those. So phase one is defining your needs. And what's really, really important here is defining what is your existing system. And so when I say that, I say metering, 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 data, data, data. So even before you hire a consultant, something you can do today, right now, is to look at collecting thermal electrical load metering data. And ideally, that would be at an hourly or sub-hourly resolution, because that's going to be really important once you bring on a consultant. They can get a clearer picture of your load profiles, which will be super important when you're picking out equipment and different solutions. So phase one, there's a lot of data collection. In phase two, we really emphasize optimizing your existing system. So I talked about reducing load in those buildings served. So not only are you going to look at optimizing your central plant, looking at any issues with your controls, you're going to do that at the building level as well. So we really emphasize doing energy efficiency projects before coming back and trying to find solutions for your central plant. And the goal there is to really reduce your loads. So that way, when you size the central plant retrofit, it can be properly sized for those more efficient buildings and reduce your overall cost. And in phase two, you may even end up doing retro commissioning, especially if you determine that you have a remaining useful life in your existing equipment. And in phase three, that is when you'll bring in a consultant. So there may be some more advanced owner operator teams that can do phase one and two on their own, or you may bring in a consultant a little bit earlier on. It really just depends on what comes out of that phase one and defined needs. So in phase three, you're going to work with your consultant to define different options to meet your goals, and then you're going to evaluate those options and select one to advance. And by phase four, at the end of the assessment, the goal is at a minimum to have a schematic design and an implementation plan. Next slide. Okay, so we did a little preview with which phases you have completed or started in regards to your central plant. Seems like you guys were all across the board. So now I'd like to do another poll to ask you, what technologies are you thinking about implementing in your central plants? So go back over to Slido, and we'll go ahead and see what you guys think. So for our options here, we want to know who's looking at ground source heat pumps, heat recovery chillers, we have thermal energy storage, we have air source heat pumps, we have your boilers, your chillers, cogeneration. And then if none of this applies, you can hit other. Or if you're still in that really early on phase, that's fine. You don't have to answer this poll, but these are some of the technologies that we'd recommend that you start looking into. Awesome. So we have a lot of people looking at heat recovery chillers. That's great. Ground source heat pumps. And I love seeing people are selecting thermal energy storage. That is one of the findings from the working group, is incorporating thermal energy storage is a great way to reduce your equipment size, reduce cost, reduce demand. There really isn't a reason you shouldn't be trying to incorporate thermal energy storage. Okay, great. Well, I think with that, we'll go back to the slides. All right, so here, just as I was saying, we love to hear you looking at heat recovery and thermal energy storage. What I'm showing here in this graph is I'm showing that you can have the monthly heating and cooling load when you start to work with your designer. And so what they're going to do is take all of that metering data that you collected in phase one, and they're going to make a baseline energy model of your central plant. And the reason that data is so important is so that way they can calibrate their model with that trend data collected in earlier phases. So that way it's actually accurate. And you can see here what we're looking at is throughout all the months of the year, this is the modeled heating and cooling load. And you can see where you have simultaneous heating and cooling. And that's super important to look for opportunities for heat recovery and thermal energy storage. Next slide. And then here, I wanted to just emphasize the importance of defining your evaluation criteria with critical stakeholders. So that's going to happen in phase 1. You want to define what's important to you, but the place you'll use this is actually in phase 3 when you're looking at selecting a solution. So over here on the left, you can see we have quantitative evaluation criteria like life cycle cost and capital cost, but we also have qualitative evaluation criteria. So you can see we have maintenance complexity, risk and resilience. Those are things that are a little bit harder to quantify and put a straight dollar value to. So what we've done in this evaluation example is assign a number from 1 to 5 for each of these criteria across 5 different scenarios. And then at the very bottom, you can see each scenario has been given a total number. So scenario 2, which is the brightest green, has a 4, and that's going to be the highest. So using this type of evaluation helps you put number values to these different scenarios and can help you choose the best option based on that criteria. Next slide. And finally, the last thing I wanted to leave you with is just the importance of having a phase implementation. This is something that was super important in the working group. This isn't going to happen overnight. You can see here on this chart, we have 0 to 20 years. This is really long term, and planning it in those phases can help you see how you can execute this to align with other equipment replacements that may already be happening in buildings. So the first phase, you're focusing on your central utility plant. But in addition, there's some overlap where you start doing some retrofits in those buildings that are served by the plant to make sure that by the end you meet those goals that you may have for your building portfolio. All right, well, thank you all for listening to the takeaways from the Central Plant Retrofit Working Group. With that, I will pass it to Betsy to talk about some boots on the ground case study.
Thank you, Nora. Good morning, everyone. I am Betsy Eisenstein. I'm the Deputy Commissioner for Facilities Management and Decarbonization at DCAM. DCAM, the Division of Capital Asset Management and Maintenance, is responsible for capital planning, public building construction, facilities management, and real estate services for the Commonwealth of Mass. The agency was created in 1980 to promote quality and integrity in the management and construction of the Commonwealth's capital facilities and real estate. We oversee about 61 million square feet of active buildings plus surplus buildings. We manage over $3 billion in capital projects, partnering with state agencies on the full cycle of their facility strategies. DCAM directly manages approximately 3 million square feet of state buildings and approximately 2,500 acres of surplus land. We have, can you advance the slide? Here we go. We have a long history of energy efficiency and designing and building high performance sustainable buildings. And from a mission statement that working towards a zero carbon future is literally front and center. Next slide. This chart shows the age of our portfolio, and it is affectionately known as the sharp chart. The purple fin that spikes in the 60s and 70s is growth in higher ed. All of those facilities, many of which have central plants, are coming due or are past due now. Higher ed is about half of our portfolio, but more than half of our emissions. We experienced a corrections buildup in the 80s and 90s. Many of those facilities have central plants, and many of the aged health and human services facilities are also campus style with central plants. The good news in our portfolio is many of the community colleges built in the 70s were resistant electric heat, so they have robust electric systems, electric services for future electrification. So we have lots of central plants, they have lots of challenges, but lots of opportunity. Next slide. This graph shows emissions from on-site fossil fuel combustion starting from 2004 until almost current, 2023. It also shows our emissions reduction goals established by Executive Order 594 and state climate legislation. The reduction you see here so far are due to aggressive energy efficiency, fuel switching, and probably the pandemic. We're on track to meet our 2025 goals, but things get far more challenging as the curve turns steeply downward. Next slide. Executive Order 594, Decarbonizing and Minimizing Environmental Impacts of State Government, will be 5 years old in April of 2026. It continues to be a powerful tool and has become well ingrained in our design processes. New construction is relatively easy, mostly due to new energy code requirements. We get to skip the discussion about gas boilers and we go right to electrification. Existing buildings are more challenging. Fossil fuel-free options are always considered and prioritized when possible. Maximizing energy efficiency is a requirement, and a resilience survey is completed for all projects over $300,000 and considered in the project design. Important to our approach is to never miss an opportunity to eliminate or reduce on-site fossil fuel combustion, regardless of what we're doing, or to prepare for its future elimination. This takes a lot of diligence. Next slide. The overarching strategy is simple: optimize building systems, including envelopes, electrify everything, eliminating on-site fossil fuels, develop on-site renewables as much as possible, while others green the grid. This strategy also includes shrinking our portfolio. The circle on the left has to get smaller. We simply cannot afford to decarbonize the full complement of buildings currently in our portfolio. Next slide. To achieve these goals, we created a strategic plan, which is really a plan to get a plan. It was a very simple but helpful exercise that forced us to think at a high level about our entire portfolio. We assessed opportunities and challenges for each sector and within the sector. We thought about how to best approach building types, campus style versus standalone, large versus small, and special challenges within the sector like historic buildings or brutalist architecture. Next slide. We have settled on a decarbonization roadmap approach for our campus style facilities, central plant or not. Roadmaps are location-specific, high-level plans for each campus with the goal of no fossil fuel combustion by 2050. To date, the Commonwealth has completed or is in process with roadmaps for 23 out of 29 higher ed institutions. We have also completed roadmaps for corrections facilities, group homes, trial courts. And we are just getting going on a roadmap for one of our state office buildings. We're learning how to do this better, faster, and less expensively. A few years back, the DCAM commissioner at the time challenged us to have 2 decarb pilot projects on the capital plan the following year. So we did just that. At the moment, we have 3 design build decarb projects in design, each started with the roadmap. I'm going to discuss the first one in a little more detail. Next slide. Pilot project number 1 is at Massachusetts Maritime Academy in Buzzards Bay. That's on Cape Cod, or the Cape as we call it. You can see that this is a campus with some resilience challenges. That is water on 3 sides. This project started with a master planning challenge. How can the campus grow while reducing emissions? We added the decarb roadmap to the master planning effort, which was a winning combination. This campus once had a central plant, but it was decentralized years ago. There are now gas boilers in each building, many of them in areas of potential flooding. Additionally, the master plan called for a new STEM building. Next slide. This is the roadmap. The plan was developed in conjunction with the master plan. You probably can't read it, but it is meant to show the phases of work needed to get the campus to fossil fuel free by 2050. And it looks a lot like the chart that Nora just showed. The plan contemplated building infrastructure to support the first 10 years of the master plan, tying in the buildings that were most ready for low temperature hot water and doing aggressive energy efficiency. Future building tie-ins will be more invasive and likely best done with major renovations. The decarb project became an enabling project for the new STEM building, the 4th one down on the plan. and an important focus of the master plan. Next slide. The project's concept includes a neutral hot water loop, which you can sort of see running down the spine of the campus there, a ground source bore field in the parking lot in the upper right, heat pump plants in each building that currently have gas plants, aggressive energy efficiency to keep the number of wells and electric load manageable, a tie-in to an existing ground source system at the campus library, a tie-in to the new STEM building currently under construction, and a tie-in to other facilities that can be converted more easily to low temperature hot water. Slide. The current state of the project is a design build contractor is working on the design. We just issued a contract amendment for the energy transfer loop and 120 wells out of a total of 252 to ensure that the neutral temp water will be there for the new building. Like most projects, this one is facing cost pressures and contemplating how much to do now versus build for the future. Maintaining aggressive energy efficiency measures is critical. Next slide. The new STEM building at Mass Maritime is currently under construction. It was designed in conjunction with the energy transfer loop to be a high-performing all-electric facility. It is also built up 5 feet above the existing grade to protect the structure from future flooding. These two projects, the STEM building and the supporting decarb infrastructure, are off to a great start. We have 2 other decarb pilots just behind, but we have many, many more to go to meet our 2050 goals. Next slide. So to quickly conclude, it is complicated and it takes a while and it's often overwhelming, but next slide. It is possible and we are making progress. I mentioned the 3 pilot projects that are in design, and we have a few new decarb projects on deck. Any new construction is fossil fuel free, although we don't do too much new construction. Last summer, we celebrated 10 years of net zero operations at the Fish and Wildlife headquarters pictured here in this slide. We built our first passive house certified facility, and we're learning along the way. We continue to refine the process. But every project, new construction or otherwise, pursues efficiency, resilience, and emissions reductions. And we like to say every project is a decarb project. Thank you. And I think those are some links to the executive order and guideline documents, if those are of interest. And now I will pass it off to Rob.
Thank you so much, Betsy. Appreciate that. Before we transition on over to Rob, just a reminder to folks in the room, if you have any additional questions coming up, please go ahead and go to www.slido.com and put in that event code #DOE. And we look forward to hearing questions at the end. That was really helpful just to learn from Betsy around the many different projects and ambitious work going on across the Commonwealth of Massachusetts. Next, I'll pass it on over to Rob, who is Carleton College's Manager of Campus Energy. Thank you for being here with us, Rob. I'll pass it to you.
Wonderful. Thank you, Bree. Next slide. Good morning, everybody. As Bree said, my name is Rob Hansen. I'm the Manager of Campus Energy at Carleton College. Today, I'm going to be walking you through our district's heating and cooling conversion from steam to hot water. So next slide. Just to give you a little bit of background on our campus, we're a small college, about 2,000 students in Northfield, Minnesota. So we're about 45 minutes south of Minneapolis and St. Paul. Next slide. For a big overview of our energy system on campus, we have 2 1.65 megawatt wind turbines. One is connected to campus, one is not. We have about 480 kilowatts DC of rooftop PV. And over the past 2 years, we've built 11 passive house certified student townhouses. So, and then we use a lot of natural gas and electricity, but a lot less natural gas, and that's what I'm going to be telling you about today. So next slide, please. Okay, so talking about our original district system, next slide. Up until about 5 years ago, what you see is what we had for heating. We had a district system, we had boilers at a central plant, and whenever we needed heat, we'd turn those boilers on. They would generate steam, and we would pipe the steam around campus in underground tunnels. That steam would enter buildings, and then it would go into either radiators or coils, and it could heat any given space we piped it to. Next slide. Our cooling system was pretty similar in the sense that we still have a district system, but whenever we needed cooling, we would turn on the chillers, which were located in the same central plant, and we would pipe 40-degree Fahrenheit water underground through pipes to buildings, and that chilled water would go to coils and provide air conditioning for that space. Next slide. So it's just about 10 years ago that our facilities team determined a few things. And that was one, our big old steam boilers a few of them in particular were getting rather old and we're going to be in need of a replacement soon. And two, a lot of our steam pipe was inching towards 100 years old. And so we would need to be replacing that. So instead of replacing like for like with old technology, we thought this would be a good opportunity to replace with updated technology that we could heat campus and cool campus more efficiently. So that meant we were going to get off of steam and switch onto hot water. And for that to happen, this is a massive project. But in general, there were three things we needed to do. So next slide. First, we had to replace our steam boilers, which you see on the left, with newer technology. And so we were going to install heat pumps, which you see up top, and then we knew that wasn't going to provide all the heating we needed. We are in Minnesota, so we have pretty long and pretty cold winters, so we're going to need some supplemental heating. So we're also going to install some condensing natural gas boilers. So we had to make the heat. This is how we made the heat. Now we had to move it to buildings. So next slide. We had to update the distribution center. Excuse me, the distribution system. So we used to pipe steam, which was very hot, and we could use relatively small pipes, and we needed to replace this with bigger pipes that we could pipe hot water to buildings. We're lucky in that a lot of campus for our distribution system, we have tunnels. So you can see that on the left, and replacing the pipe in tunnels is easy. I should say relatively easy. We were able to open up those tunnels, take out the old pipe and put in the new pipe. On the right, you'll see directly buried pipes. Sometimes we had to do that as well. And so we had to replace all the piping. And then we also had to update the building. So next slide. On the left, you'll see kind of an older style of radiator that needs either steam or very hot water to provide heating. And we were going to be updating our system to hot water, specifically 120 degrees Fahrenheit. And so we had to update the radiators for a new style of radiator that just has more surface area, so it can still heat a room properly. And we also had to update coils in air handlers. So if you're not familiar, think of coils as small radiators that are in the ductwork. Next slide. So we had to update those three portions of the system. So our old system, whenever you can go back, our old system, whenever we needed heat, we would turn on the boilers and send steam. Whenever we needed to cool a building, we would turn on the chillers and send cold water. It was relatively simple. Starting in 2020, when we were done with the conversion, it got a bit more complicated. And so starting then and currently we have 3 HVAC modes. So next slide. The first mode is simultaneous heating and cooling. And so how this works is utilizing a heat pump. We're able to move heat around. There are going to be some buildings on any given day that are too cold and they need heat. And then there are going to be some rooms that are too hot and they need to be cooled. And so what we can do is using our heat pump and distribution system, we can take heat out of the hot room, which cools it to a comfortable temperature. And we give that heat to a cold room, which heats it up to a comfortable temperature. So that's one of the most efficient ways you can heat a building, in our case, a campus. But we're going to max that out. So if you go to the next slide, once we max out simultaneous heating and cooling, that's when we call on our geo-exchange system. Sometimes colloquially, geo-exchange is called geothermal, but specifically our system is geo-exchange. And what that means is in the winter, we're able to pull heat out of the ground and run it through a heat pump, and then we can pump hot water to buildings around campus. And then in the summer, we're actually able to pull heat out of the buildings to cool them and put it in the ground. And ideally, we can use that heat later in the winter. So we installed a big geo-exchange system. We have about 300 bores on campus. But we knew this alone wasn't going to provide all the heating campus needed. So if you go to the next slide, as I alluded to earlier, we were going to need some supplemental heating and cooling. So on the left, you have some natural gas condensing boilers. On the right, you have chillers. And so we knew in the depths of winter, we were going to max out simultaneous heating and cooling. We were going to max out geo exchange. So we turn on these boilers. And on the really hot days of summer, we knew we'd also max out the first two modes, in which case we had these supplemental chillers to help cool campus. Next slide. So energy savings. Next slide. We'll see a bar chart here, and this is our natural gas usage on our main campus, going back about a decade. And you can see when we transitioned from steam to hot water between 2019 and 2020, we significantly reduced our natural gas usage. So last year we used 72% less natural gas usage than a decade before. Next slide. Our heat pumps run on electricity, so we knew our electricity usage was going to go up. But as you can see, a 21% increase is not nearly as drastic as a 72% decrease in natural gas usage. So if we go to the next slide here, if we're kind of combine electricity and natural gas units, overall, we're using about half as much energy on campus as we did a decade ago. Next slide. So I'm going to take you through 4 quick key takeaways that we learned during this project. So next slide. Geo-exchange, sometimes called geothermal, very popular. A lot of people are, that's a hot thing to do around on a lot of campuses. And we have it, it's great. However, with our system, because we had steam beforehand, we had to prioritize transitioning from steam to hot water. Had we just put in a geo-exchange system while we were still running on steam, we would have gotten nowhere near the value out of the whole geo-exchange system. So because we were on steam, we needed to prioritize getting off steam before we could consider geo-exchange. Next slide. So as I mentioned earlier, we had to replace, we had new heating equipment, heat pumps and boilers. We had to put in new distribution pipes. All that had to be done between 2 winters. So in one spring, summer, and fall. However, updating the buildings and updating all the coils and radiators and building control systems, we had a bit more flexibility. And so the slide is a bit more complicated, but in general, we could thoughtfully update buildings on a slower schedule. We're still finishing some updates on these buildings about 5 years in, and we're able to still make do with some of that original equipment as we prepare to replace that building equipment. Next slide. During this project, we had to start thinking about heat differently. We had to think like a heat pump. So I know personally myself, before coming to this job, I would think of heating and cooling as separate things. You either have cold or you have heat. That's not the case. If you think like a heat pump, there's either heat or there's less heat. And so that's kind of the idea that heat pumps work on. So we're prioritizing moving heat as opposed to making heat on campus. And last slide. Speaking of thinking of heat differently, if you think about heat differently, all of a sudden you open yourself up to looking at other sources of heat. So for example, we have some solar thermal on campus. We could expand that. Electric boilers are an option. Ideally, they'd be powered from renewable electricity. Wastewater heat recovery is something we're looking into because wastewater is hot year round, and also expanding our geo-exchange system. So with that, I know that was a lot of information, but I'm going to pass it over to Bree. Thank you.
Thank you so much, Rob. Really interesting to hear the varying different details and examples across leadership of Carleton College. So appreciate you sharing that story. All righty. Want to thank all of our panelists for the insightful presentations that were shared. Before we transition to the Q&A, and I'm seeing them flow in, a lot of great questions and excited to transition to that quickly, we want to encourage you to download our additional resources handout. We'll share the link in the Zoom chat box as well. This will pull some of those resources noted from Rob and Betsy throughout on our speaker's topic and the varying strategies they've taken towards central plant efficiency and reliability. We hope folks find this useful. Next, if we transition to the next slide, I will pass it on over to Nora to get into our facilitation of our Q&A.
Awesome. Thanks, Bree. All right, Rob and Betsy, we are going to do our Q&A session. So I will do some of the questions are for both of you, so I'll give you both a chance to answer. And then we had a couple that were specific based on your wonderful presentations. So this first question here has the most likes. It is, what are the most common inefficiencies you see in existing central plant systems, and what low cost or no cost strategies can address them? Betsy, maybe we'll start with you on that one.
Well, I can say one issue that we see is the inability or unwillingness to shut plants down for the summer on a campus when steam is not needed. There's generally a reluctance, and often for good reason, to do that shutdown, but it's running with all its losses for 3 months, which is 3 months or longer.
Can you expand a little bit on kind of why you feel like there's hesitation to shut down the central plant? And then I'll pass it to you, Rob.
I think that there's concern about the integrity of the steam line and the steam systems in general. They were built, they're old. The ones that have these issues are old, and they were built to run. And there's just concerns that things will not come back when they're needed most.
That makes sense. Thanks, Betsy. Rob, what are your thoughts here? Common inefficiencies you see in existing central plants and no low-cost strategies to address them.
So I can't speak about other plants, but I can speak about our plants. Something I didn't cover during my presentation. So I didn't cover cost, and transitioning off of steam onto low temp hot water is not easy to do, especially between 2 heating seasons, and it's not cheap. However, our financial payback is under 20 years. And so that's a lot to stomach. Of course, it's a lot of work, it's expensive, but we plan on being here far longer than the next 20 years. And so while it is not cheap or no cost by any means to transition off of steam, it's one of those things we were able to make it work with just a lot of timing lined up and a lot of planning. And in under 20 years, it's gonna break even, and then it's great from there. So I just wanted to point that out.
Great. Thanks, Rob. So the next question is kind of about a little bit more about maintenance staff. So Betsy, you kind of alluded to this, just kind of with sometimes on-site staff are unwilling to make changes. They're used to doing things a certain way. So my question here is, was your maintenance staff open to the switch to heat pumps? Like, how did you kind of shepherd them along in these major changes that you made to your equipment? And I'll start with you, Betsy, and then pass to you, Rob.
Well, so GCAM is in an interesting position as we have an oversight responsibility. We are not managing day-to-day operations, so we do work with the campuses or the facility and their staff to sort of bring them along. And we have found great value in the road mapping process, in including everyone who wants to participate, so that people really understand where we're going and why. And we have seen in several instances where we started with, I will call people who were very large fans of steam systems, to being true converts by the time we got to the end of just the study process, and really very interested in moving to the next technology. So we have not seen too much pushback.
That's great. Thanks, Betsy. So it sounds like engaging people very early on so they have a say in the process really helps them become converts and fans of heat pumps. That's awesome. What about you, Rob?
I'd agree with what Betsy said. And to speak from our transition off of Steam, we were having a hard time finding licensed boiler operators, and I don't think we were alone in that. And because this was a plan more than 5 years in the making, we had time to plan, and it lined up. The timing worked out well for some upcoming retirements of some of our boiler operators. And in that transition, we found maintaining the slow temp hot water system has been quite a bit easier than maintaining a steam system. And so overall, it's worked out very well, and but that planning ahead just to kind of try to smooth things out was helpful.
That makes sense. And then this one, I will stick with you, Rob, because I think it's specific to your project. In addition to the steam to hot water geo exchange, was any facility envelope improvement done?
Excellent question. A little bit. Our campus was founded in 1866, and we have a lot of old buildings on campus, and so that definitely that's a challenge. Updating these envelopes is a big challenge. So there has been some envelope work, especially windows, that we've worked on, but since this project began, and we're still kind of updating building HVAC and control systems, we haven't been prioritizing envelope unless there was clearly a severe issue going on. But excellent question.
That makes sense. Betsy, I'm curious if you have anything to add, if building envelope is kind of in that roadmap for your buildings you oversee.
Ideally, yes. Practically, not always. It depends on the situation and the level of renovation. I would say we have several examples where envelope is being upgraded, and we probably have as many examples of where it is not.
That makes sense. So I have another great question that I think I'll ask both of you to speak to. I'll start with you, Rob, but this one is, how do you get traction and buy-in from stakeholders to undertake a large, significant CapEx projects as presented? Just as we know from the working group, funding and financing is always a large barrier. So can you talk a little bit about how you're able to get buy-in into these projects?
I should start off by saying that this happened before my time here, but how did we get buy-in? So with the design work, where it was estimated that this project would break even in under 20 years, that was very helpful. And there was some logic in there that the timing lined up such that it would never get better to do this project than now. We had different building renovations that we had scheduled during this period that we could update their HVAC system. We were going to have to update these boilers and all this and dig up all this old steam pipe anyway. So if we were to do it now, this would be the best time, period. And if we didn't do it now, it would hard to justify this ever, in which case we'd be saying we're going to be on Steam forever. So there's a lot of good timing to get this done, and then the payback in under 20 years was very helpful as well.
Yeah, I think that makes sense. It sounds like, in short, the stars aligned for you all to do this project. And, since you are a college, you're, like you said, you're not going anywhere. So even though it was a 20-year payback, those buildings will still be there. What about you, Betsy?
I'm sorry, could you just repeat the question?
Sure. Yeah. So how are you able to get traction and buy-in from the stakeholders to undertake such a large, significant CapEx project?
It absolutely helps to have an executive order. I highly recommend it. We, like Rob described, are trying to hit that sweet spot in all of our facilities where equipment is due, hopefully not overdue, and it is kind of now or never. That is really tricky at scale. So we win some, and there are others that we just have to agree to Band-Aid for a little while until we can come back with the bigger project. So we are, the Commonwealth of Massachusetts is very aligned with this work as a priority right now.
Yeah, that makes a lot of sense. And I think both of you kind of alluded to this, but you're not just looking at the first cost of the equipment, especially in the building served, because there may be that incremental cost, meaning you were going to have to replace something anyway. So what's the extra cost to do this major retrofit? Does that kind of sound okay? Yeah, and so that's what I was alluding to in that chart where I was showing evaluation criteria. I think something we learned from the working group is just that you can't only look at first cost, and maybe, you know, everyone loves simple payback. It's a very simple, in the name, simple measure. But you're probably going to be looking at life cycle cost and some of those other qualitative criteria that, you know, is not as easy to define, but I think is really important in these situations. Well, thank you both. Let me take a look here. Let's see what is coming up. There's one for you, Rob. It may not apply since you said the project was decided before your time, but do you have any information on how you all decided on geo exchange? And were other technologies considered?
Yes, yeah, no, I can speak to that. We were the reason GeoExchange ended up being a really good fit for Carleton, kind of like Nora mentioned earlier, the stars aligned. Our campus was set up inadvertently very well for this. We're a relatively small campus, and we had about 3 pretty big, think of quads on campus without trees that were pretty centrally located. And then we were going to be building this expansion on the science building, which was in the middle of all these 3 fields. Like all of it made sense. All of a sudden we could put geo exchange boards in these 3 fields. They all go to this very central building. It worked out. It worked out. Had we not had those fields, had we not had all this space, had we been in the middle of the city, because we're not, we're on the edge of a small town, it probably would have been a lot harder. But geo exchange ended up being a great fit for this campus.
Awesome. That makes sense. Thanks, Rob.
Yeah.
This is actually a related question, so I'll start with you, Rob, and then Betsy, see if you have anything to add. But it sounds like these are really kind of invasive projects. You're ripping out things from underground, you're drilling into the ground. So how did you handle disturbances during these projects?
Great question. Right. So we're a campus, and luckily we have about not too long, 10 weeks every summer, that kind of between academic terms. So we try to pile as much in those 10 weeks as we can. But considering the scope of this project, yeah, you know, our central quad was closed for over a year, which is not ideal for a campus when that's such kind of the beating heart of campus. But we needed to do it, and we had buy-in from campus to do this. We had to buy a lot of goodwill by handing out a lot of earplugs and granola bars because there was a lot of geobore drilling right outside of a lot of residence halls. So you know, we asked for patience, and now that it's done, it's a lot, you know, not a problem, but it was invasive, yes.
That makes sense. I think you could buy my goodwill with a couple granola bars, some free treats, you know.
Yeah, I'll take it. Yeah, yeah.
That helps. Betsy, I know you're kind of overseeing a lot of different projects, but have you gotten any feedback on how to handle the disturbances during construction for these types of projects?
So the Commonwealth has done many ground source well projects. The ones we're doing now are the first ones at scale. All the others have supported an individual building, but sound mitigation is super important. When near a neighborhood, sometimes offering vibration testing is important. Communication is hugely important. And in higher ed, figuring out a way to let students participate either in a seminar or run a class about it goes a long way. So we really try everything. And our first at-scale project will be coming up very soon, next couple of weeks. So we'll see. But neighborhood communication is very important.
Thanks to both of you. Did you have something to add to that, Rob?
I just want to jump on Betsy. I agree with Betsy on communication. We didn't want any surprises. It might be loud, it might be dusty, it might be dirty, but we don't want it to be a surprise. So there was ample communication done in advance to prevent surprises.
Yep, I think that makes total sense. Communication is key. People say that all the time because it's true. If someone knows what to expect, their expectations are level set, and then, they have the earplugs. So, well, I think this next one, I may pass it to you, Betsy, because so the question is, what is the estimated capital cost for implementing geothermal? And I know this is not a straightforward question. It depends on the place, it depends on the scale. But since you're kind of overseeing multiple projects, I'm curious if you have any just advice on this or how you're estimating costs for these projects.
So I hesitate to give a number. I can tell you that we use, when we're just throwing numbers around, we use $35,000 to $40,000 a well, but we're never really sure what's included in that number. So I don't, and we're in New England, and there's not a lot of companies drilling wells, so we have some competition and scheduling to be done. Sometimes we're competing with ourselves for the rigs. So that's a hard number for me to be really decisive on.
Yeah, I think that's fair. I think from what I've read, the cost of the drilling is like the biggest cost of the project. Are you seeing that to be true, like more than the equipment and anything else?
Well, it depends on the project. So it depends. It is expensive and invasive.
Rob, do you have anything to add about cost?
Yeah. Overall, the Carlton project for the geo exchange system plus the heat pumps was right around $42 million. However, it's very complex on how it's broken out, and then that doesn't necessarily include all of the building updates and the distribution piping as well. So like how that's broken up can be difficult, but in general, that's what it cost us to do about 7 or 8 years ago.
Awesome. Thanks, Rob. And I think we will wrap up with one final question. And Rob, I will pass this one to you. We had a question about how did you approach prioritizing the upgrades or retrofits in the central plant to maximize efficiency? And maybe that also has to do with, how are you prioritizing upgrades in your building served? I think you talked about this a little bit earlier, but maybe you can expand.
Yeah. So yeah, I'm going to focus on buildings, not so much the central plants, because the central plant went through the overhaul, getting rid of the old steam boilers and installing the new heat pumps and condensing boilers. We had to. A lot of it was timing. As I mentioned earlier, we had different buildings scheduled for renovations around the same time of this conversion project, in which case we could make sure those buildings are converted to make sure they're going to heat well off of 120 degree Fahrenheit water. But we knew that some buildings we're not going to be able to get to until quite a bit later, and we were able to figure out which buildings can we make do with the current equipment. It might not run the most efficiently using these old radiators and old coils with 120 degree water, but can we make it work to buy us time to update those? So I had my slide and if this person would like to reach out to me and chat more, I'm happy to do so. But we're able to kind of cut campus in half in the winter on different temperatures, going to different buildings as we kind of finish updating all buildings to run off of 120-degree Fahrenheit water.
Got it. Thanks, Rob. Just cut
Yeah,
your campus in half. There you go.
there you
Easy
go.
peasy.
Yeah.
All right, well, we can go back to the slide deck. I just want to thank everyone for the questions to our panelists today. Thank you both for your insightful responses. We really appreciate it. Feel free to contact our presenters directly. Like Rob said, reach out to him if you have some more questions on how you prioritize. We have our names and emails here. And I also encourage you to follow Better Buildings on LinkedIn, on X for the latest news. You can see our handles here next to the respective icons. We have all the social media. We are very hip. And I wanted to let you know that you will receive an email notice when today's recording and slides and the transcript are available on the Better Building Solutions Center. So I thank everyone for being here today, and I hope you have a great rest of your day. Take care, all.